Hey everyone, so today we're going to talk about discrete and continuous random variables. A random variable is a variable which represents the outcome of a trial or an experiment. So for example, coin tossing. The sample space of coin tossing will be head or tail, which means that you can either land on head or land on tail. The random variable, we can set the random variable x to 0 and 1. We can set head to 0 and tail to 1, or tail to 0, head to 1. But in this case, we will use head as 0 and tail as 1. So what is the probability that what is the probability of x is equal to 0? The probability of x is equal to 0 means the same as the probability of landing on head when tossing one coin. In this case, it will be 0.5, which will be 1 over 2. And the probability of x is equal to 1 means the same as the probability of landing on tail when tossing a coin. And the probability will be 0.5, which is 1 over 2. What about tossing a coin 3 times? Here's the sample space. The H's are representing head, and the T is representing tail. And the sample space will be HHH, HHT, HTH, HTT, THH, THT, TTH, and TTT. We can set the random variable x to be the number of tails. And then so x can be 0, 1, 2, or 3. So if x is equal to 0, that means you landed on heads all 3 times. If x is equal to 3, that means you landed on tail 3 times. And then if x is equal to 1, that means you landed on tail 1 time and landed on heads the other 2 times. If x is equal to 2, that means you landed on tail 2 times and head 1 time. Discrete random variable. Discrete random variable has a countable number of distinct values. It is obtained by counting. For example, the number of students absent on Friday, the number of calculators you have, the number of water bottles you have, the number of pens you have, the number of erasers you have. Continuous random variable is a variable that takes an infinite number of possible values. It is obtained by measuring. So, for example, weight of students in class and temperature in the desert, or the height of students in class will all be examples of continuous random variable. And the continuous random variable can be represented by density curves, and we will give an example of density curves later on. So practice. Try to see if the given event will be a discrete event or a continuous event. In other words, will we measure it or will we count it? So pause the video and try. The speed of race car will be continuous since we will be measuring it and it's not countable. it can take on infinite values. It can be for example 258 miles per hour. It can be um 280.5 miles per hour. Anything. And the time it takes to take a test will also be continuous. You can take 60.5 minutes. You can take 60.111 minutes. Anything. The number of universities in the US is discrete. That means that you cannot have 800.5 universities. You can either have 800 or 800 or 801 university. And then in the case of the number of candies in a jar, it is also discrete. You cannot have 0.11 candy. Then discrete random variable practice. So this is an example of a problem that you will need to use a discrete random variable. In the opaque box, there are 15 identical balls with different colors. Excuse me. 3 red, 5 yellow, 4 green, and 3 gray. The question 1. What is the probability of drawing a green ball? The probability of drawing a green ball will be 4 over 15. Why? Because there are 4 greens out of the 15 balls. And since the balls are identical, they each has an equal chance of being drawn. So then the probability will be 4 over 15. And then what is the probability of not drawing a yellow ball? To find the probability of not drawing a yellow ball, we need to find the probability of drawing a yellow ball, and then use 1 minus that probability and get the probability of not drawing a yellow ball. So the probability of drawing a yellow ball will be 5 over 15, and then we use 1 minus 5 over 15, we get 10 over 15, which will simplify to 2 over 3. So then the probability of not drawing a yellow ball would be 2 over 3. Continuous random variable. So this is an example of when we use continuous random variable to calculate the probability. To the right is a uniform density curve, meaning that the probability of all outcomes are the same. So question 1, what is the probability of x is less than 4? We can get the probability by multiplying the area under the curve. The area under the curve for uniform density for any density curve will equal to 1. But for x is less than 4, we can see that the length is 1, 2, 3, and the height is 0.25, which we can use 3 times 0.25, which will give us 0.75. Yes. What is the probability of x is equal to 4? Well, the probability of x is equal to 4 will be a vertical line. But then the vertical line is equal to 0 because it does not have any length in there. So then it will be 0 times maybe 2 point, sorry, excuse me, 0, it will be 0 times 0.25, which will then be 0. And now what's the probability of x is less than or equal to 4? To find the probability of x is less than or equal to 4, we need to add the probability of x is less than 4 and the probability of x is equal to 4. So if we add them, we'll get 0.75 plus 0, as we get from the previous two questions. So then the probability of x is less than or equal to 4 would be 0.75. And then we see that the probability of x is less than or equal to 4 is equal to the probability of x is less than 4. They're all 0.75, since the probability of getting x is equal to 4 would be 0. And that is it. Thank you.